Hello from the lab. In the next video series, we will distill palinka. We will go through a complete distillation process step by step with each machine of our in-house product line. All three machines have the same water-jacketed, double-walled kettle with a gross capacity of 100 liters. The machines are available with different heating options, such as gas, electric, or wood. To ensure a proper copper surface, our column still models have a catalysator and copper rings. Here, from the test room, we will show you distillation technology videos, but a separate technical description of the machines will be available as well. And we will also share details about the design and manufacturing technology. In the distillation technology videos, our machines are all fully equipped. For more information, please visit our website. In this video, we will walk through a complete column still distillation process, including all the necessary steps. The machine is a 100-liter heightened column still model. There are 3 sieve plates on the machine, and the net capacity of the kettle is 80 liters. We will go through each step involved in the distillation process and show you the details, from loading to draining. The first step is to remove the loading door. Manual loading is easier with the help of a loading funnel, which can be placed on the loading door. After filling in the mash, remove the loading funnel and add the appropriate amount of anti-foaming agent. The purpose of the anti-foaming agent is to prevent the mash from burning and sticking to the wall of the kettle and to prevent the mash from foaming during the process. Put the loading door back before starting the heating process. Before starting this heating process, check the followings and perform the following tasks. Double-walled water jacket is filled with water to its maximum capacity, approximately 10 centimeters. Safety valve is closed. The vacuum valve can be periodically flushed with water. To avoid leaking due to dust or other contamination, connect the water in and open the water in tap. The wastewater can be drained from the machine through the connection below. To fill up the end cooler, open the valve on the first rotameter. By opening the valve, cooling water flows into the end cooler. Keep the valve open until the cooling water appears in the drain pipe. Fill up the dephlegmator by opening the rotameter on the right. The dephlegmator must also be filled until water appears in the drain pipe. After that, you have to close it. Let's prepare for the collection of the heads and place the numbered jars. The lever of the 3-way tap must be in the upward position so that the presented flow can occur, and the distillate can flow into the distilling parrot. Tighten the spout and place the parrot under the spout. To collect the heads, we recommend opening the tap on the parrot and making sure that the heads can flow into the jar. To set the sound signal, please do the followings. Press the All Set button. You will see that the upper sound signal threshold is flashing. We would also have the option to set a lower alarm threshold, however, in our case, The upper sound signal threshold is the interesting one, because as soon as the mash reaches 90 degrees Celsius, we want the sound signal to occur. In the case of the deflegmator thermometer, the first sound signal is set to 35 to 40 degrees Celsius. Connect the machine's lights. Turn on the main switch. Press the safety reset. Start the mixer. Turn on the electric heating power. 6 kilowatt, 4 kilowatt, 2 kilowatt, so a total of 12 kilowatt. Turn up the pot meter to 100%. This pot meter controls the 2 kilowatt power independently. The heating process began by turning on the heating power. The temperature of the loaded mash was at room temperature, approximately 20 degrees Celsius. The heating phase will last until we reach the boiling point of the mash. The boiling point of the mash depends on the alcohol content of the loaded mash. The higher the alcohol content is, the lower the boiling point will be. An average pear or apple mash that we just filled in has an alcohol content of approximately 5–7%. In this case, the boiling point will be around 94 or 95 degrees Celsius. We set the sound signal of the mash thermometer to 90 degrees Celsius, and it warns us that we are approaching the boiling point. The sound signal can be stopped by pressing any button. When the mash temperature reaches 90 degrees Celsius, we switch back from 12 kilowatt of heating power to 4 kilowatt. This is a double-walled, water-jacketed kettle with a maximum pressure of 0.5 bar. The maximum 0.5 bar is set by the safety spring valve below. At 0.5 bar, the temperature of the water in the double wall during heating can be a maximum of 110 degrees Celsius. During the heating phase, the pressure on the manometer starts to increase, and then we have the opportunity to vent the kettle by unscrewing the second safety valve. We suggest filling up the vacuum valve with a little water from time to make sure that it is not bubbling or releasing over pressure. This can happen because the vacuum valve needs to get some air after distillation as the pot cools down, and sometimes dust or other contamination can get trapped under the rubber membrane. The mash temperature is currently 90 degrees Celsius, and we can no longer touch the bottom part of the column. It is warm sufficiently because the steam generated from the mash enters the column and it starts to heat up the column. We open the rotometer of the cooling water that enters the deflegmator and set it to above 160 liters per hour. At this stage, we need to make sure that the plates can fill up, but the temperature on the deflegmator thermometer doesn't go above 70 degrees Celsius. You can see that the temperature on the deflegmator thermometer is increasing, and if you look at the column now, you can see that the upper plate is already filled. The plate below will soon fill up as well, and when all three plates are bubbling evenly, we reduce the amount of water flowing through the rotameter, thus allowing the steam to break through the deflegmator and then go into the end cooler. It will cool down in the end cooler and the distillate will start to flow out, so we can start collecting the heads. Collecting the heads should start slowly. It's usually dripping and flowing like capillary. At this stage of the distillation, the handles of the plates are in the upward position, ensuring that the column concentrates to its maximum, meaning that we can separate the smallest possible amount of the heads with the highest concentration, without losing any aromas. You can see at the moment that the upper sieve plate is already bubbling evenly. The middle one is also filled, and the lower plate is not yet filled, but will be soon. This stage is ensured by the excess of water entering the deflegmator, so that the steam cannot pass through. All the steam that passes through the column condenses in the dephlegmator and flows back in the form of reflux. This stage is called the total reflux stage. Before the start of the heads, we set the rotameter of the end cooler, so the amount of cooling water entering the end cooler, to 40-60 liters per hour. We reach the boiling point of 95 degrees Celsius from a mash temperature of 20 degrees Celsius in roughly 50 minutes. Before the start of the heads, all three plates are bubbling evenly. The column has reached equilibrium. The amount of water entering the dephlegmator is reduced to approximately 40 to 50 liters per hour. This way we can ensure that the temperature on the dephlegmator thermometer will increase. We set it to 35 degrees Celsius before. The temperature will start to increase rapidly, which means that the steam is already in the upper swan neck. And when it reaches 78 degrees Celsius, which is the boiling point of alcohol, the heads will start, even slightly before that. It condenses in the end cooler, cools down as it flows down, and within a very short time the first few drops of the heads will appear. The heads start to flow into the distilling parrot, slowly, in drops, and we will collect 1 deciliter in each collecting jar under the parrot. The boiling point of the mash at the start of the heads is 95 degrees Celsius. We keep the temperature on the dephlegmator thermometer low at this time, at 77-78 degrees Celsius. The amount of water entering the dephlegmator is 30-40 liters per hour. The heads flow evenly, and since about a deciliter has flown out, we will move on to the second jar. Our first 2 deciliters of the heads have already flown out, so we switch to the third collecting jar. You can see that the outflow rate is slow. The distillate flows like capillary. During the collection of the heads already have a high alcohol content of around 90 degrees. Its character is extremely pungent due to the components of the heads it contains. It has a smell most similar to technocoal glue. It is not necessary to taste it. Only smelling it will be enough to do the separation. Its characteristic components are acetaldehyde and ethyl acetate. They are responsible for this very strong, pungent, penetrating odor. And for this reason, we do not want it to go into the distillate, more specifically into the useful part of the distillate, the so-called heart, which will arrive after the heads. We can classify the heads as it flows out by continuously smelling it, and as long as this penetrating odor is still there, we collect it into separate fractions. After a while, when a certain amount of the heads has flown out, you can experience that this strong, pungent character of the heads ceases, and after that the distillate changes to the middle stage, called the hearts. Its characteristics are the appearance of fruit aromas and, due to the high alcohol content, the characteristics of alcohol, a pungent smell, which can be a bit disturbing, but it's not a mistake. When classifying the heads, since its alcohol content is concentrated and somewhat disturbs our sense of smell, we can dilute it with water, approximately twice as much, so that it is easier to tell if it can be classified as the pure fruity hearts, or if it's still the pungent acetone-like heads. In our case, the third jar, so the third deciliter, has already proven to be quite clean, so we will switch to collecting the hearts. Later, we will have the opportunity to independently classify and smell these jars, and we will be able to determine where the border is between the heads and the hearts. We believe that the fourth or fifth jar, which we are now switching to, already contains pure hearts. Since the sensory characteristics of the distillate have already been cleared, The character of the heads is no longer noticeable in its smell, so we switch to collecting the hearts, which means closing the tap at the bottom of the parrot and placing the alcohol meter in the parrot. We then wait for the parrot to fill up. During this time, we remove the heads from here and we place the collecting jar for the hearts under the spout of the distilling parrot. During the first stage of the hearts, we will have the opportunity to reduce the resistance of the column using the handles of the plates. If we look at it now, the bubble plate has emptied and the reflux has flown to the lower level. So we can turn off one column level, or we can set two column levels to the middle stage in order to reduce the resistance of the column and allow the vapors of the distillate rich in alcohol and aromas to easily pass through the column, which is a characteristic of the first half of the hearts. This way we can ensure that we get a perfect distillate in both taste and aromas. We are at the beginning of collecting the hearts. The mash temperature is 96 degrees Celsius. The boiling point was 95 degrees Celsius, so we haven't extracted too much alcohol yet. The amount of water flowing through the rotameter, which enters the dephlegmator, is currently set at 15-20 liters per hour, and the cooling water entering the end cooler, which helps with condensation in the end cooler and cooling the distillate, is currently set at 40 liters per hour. In the first half of the hearts, the alcohol content is high, 92 degrees of alcohol. You can see that the pressure is extremely low, currently 0.1 bar. This is possible because the kettle has a proper heat transfer surface, and the heating power entering the kettle is immediately used to heat the mash, so the pressure cannot go higher. During the heart stage of the distillation, the rotameter that enters the dephlegmator must be regulated in a way that the temperature on the dephlegmator thermometer can be between 79 degrees Celsius and maximum 81 degrees Celsius. If this temperature is too high, i.e. above or approaching 84-85 degrees Celsius, it is possible that components of the tails may also be present in the hearts, so we must constantly monitor this thermometer and, if it goes higher, we usually let it go up till 80-81 degrees Celsius. But if it goes higher, more water is needed in the dephlegmator by opening the rotameter valve. During collecting the hearts, we suggest setting the sound signal of the dephlegmator thermometer to 81 degrees Celsius. If the temperature goes above 81 degrees Celsius, then our thermometer will alarm us. In this case, the best option is to open the rotameter for a short time in order for the temperature to drop back to the desired value or below. In order to do this, we can open the rotameter even more drastically, and you can already see that the temperature has significantly dropped. Then we need to reset the rotameter. For example, if it was 40 liters per hour, we set it a little higher, to about 50 liters per hour, so that our temperature balance does not go continuously up. If we open the water flow of the rotameter and add too much water to the dephlegmator, then the temperature will decrease and we may experience that if it drops below 78 degrees Celsius, the distillate outflow will slow down and sooner or later will stop. This is not our goal, so we try to control the rotameter entering the dephlegmator in a way that the temperature on the thermometer is between 78 and 81 degrees Celsius during the collection of the hearts. The end cooler is working properly if the temperature of the water leaving the end cooler is not higher than 60 degrees Celsius. At the moment, we can see that it is about 30 degrees Celsius. We are not even approaching it. Now we could further reduce the amount of the water in the rotameter entering the end cooler. At the moment, 20 liters of water per hour is entering the end cooler. We usually don't go any lower than this. Since the surface of the end cooler is large and the cooling water is cold, the cooling efficiency is very good. At the moment, with 20 liters of water entering per hour, the water leaving is only 30 degrees Celsius, so the cooler is working perfectly. The temperature of the distillate flowing out is 21.9 degrees Celsius at the moment, so the end cooler is working well. Our goal is to control the end cooler and the amount of water entering the end cooler so that the temperature of the distillate is below 25 degrees Celsius. It can be maximum 30 degrees Celsius. The cooling water entering the machine is currently 18 degrees Celsius, which is considered cold. By this moment, the first liter of the hearts has flowed out. The alcohol content remains consistently high throughout the distillation. At the moment, it is 86 to 87 degrees of alcohol. Our mash temperature is 97 degrees Celsius. The column is bubbling evenly. We still keep the level regulators in the middle position during the first and second liters. The temperature on the dephlegmator thermometer is 80 degrees Celsius. Approaching 81 degrees Celsius, we can increase the rotameter water flow rate by a little, 10 liters per hour. The flow rate of the distillate depends on the raw material. The more alcohol it contains, the faster it flows at the beginning, with a higher volumetric flow rate. In our case, it took 13 minutes for the first liter to flow out. We have reached the second liter of the distillate. Now let's look at the status. At the moment, the alcohol content is still 88% by volume, and this will continue to remain high. The mash temperature is 97.8 degrees Celsius, and our upper thermometer shows 80.1 degrees Celsius. The amount of water entering the end cooler is 30 liters per hour, which is quite a lot. The incoming water is quite cold, around 15 degrees Celsius. Because the temperature of the water leaving the end cooler is only 30 degrees Celsius, which could be as high as 50-60 degrees Celsius during normal operation. The amount of water entering the dephlegmator is around 30 to 40 liters per hour. We are currently collecting the third liter of the hearts, and the mash temperature is 97.9 degrees Celsius. Our boiling point was 95 degrees Celsius. At least half of the hearts has already flowed out. At this point, we turn the level control levers back to the upward position. From experience, we know that we can distill up till a mash temperature of approximately 99.5 degrees Celsius. And by then we can extract the significant part of the alcohol content of the mash. The third liter of the hearts has flowed out. Let's take a look at the status. The alcohol content is at the usual high level of 85–86% by volume. Our mash temperature is already high, 99 degrees Celsius. Our rotameter is set at 50 liters per hour, which goes into the dephlegmator. The left rotameter, which goes into the end cooler, is currently at 30 liters per hour. The temperature on the dephlegmator thermometer is around 80.8 to 80.9 to 81 degrees Celsius and is increasing. Just like before, we open the rotameter again and then reset it to a higher value. Here you can see that it is difficult to keep the temperature in this 80 to 81 degrees Celsius interval, so it probably needs around 80 liters per hour in order for it not to go up continuously. This is because the alcohol in the mash is continuously used, and it is more and more difficult for the machine to extract it in such a concentrated state, so we will soon reach the end of the distillation. We finish collecting the hearts after a mash temperature of 99.5 degrees Celsius, and after collecting 3.5 liters of distillate, and move on to collecting the tails. We typically do not collect the tails, but we show it now exclusively to present how it can be classified, how it is possible to notice the characteristics of the tails. Once we have collected the useful part of the distillate, the hearts, and we are still familiarizing ourselves with the art of distillation, we have the opportunity to collect some of the tails, just to get to know its characteristics, and to be able to store these sour, unpleasant smells of the tails in our olfactory memory. We can do this by reducing the amount of water entering the deflegmator. Technically, we turn off the deflegmator. As a result of this, the temperature on the deflegmator thermometer will increase. As the temperature increases, the alcohol content of the distillate flowing out will decrease. The alcohol content at this moment is still around 86 to 87 degrees, at a mash temperature of 99.7 degrees Celsius. As the temperature rises to 85 to 90 degrees Celsius, the distillate that flows out will have the strong characteristics of the tails. One possibility is to put some sample on our hand, rub it into, and smell it continuously while our body temperature evaporates the distillate. In this situation, we should feel a neutral, or a slightly sour so-called tail character. Another method of examining the tails is to pour some into a glass. An experienced person will be able to tell quickly if the distillate has become slightly sour, or if it is neutral and there is no smell of aromas. Alternatively, a dry test can also be helpful, where we pour the distillate out of the glass, wait a while for all the ingredients to evaporate from the glass, and if we smell sour or unpleasant odors in the glass, then it is clear that the distillate that flows out has characteristics and components of the tails. Once we have finished collecting the hearts, we can turn off the heating elements. We recommend turning off the mixing motor only after the mash waste remaining in the kettle has been emptied, because due to the continuous movement of the mixer, it cannot settle and cannot cause a blockage in the spout. We close the valve of the rotamators and we also close the supply tap. We have the option of backwashing the entire system through the three-way tap. When the tap is turned on, washing water flows through the water supply into the end cooler, flowing through the swan neck and backwashing the entire column. Loosen the door during washing. Once the wash is complete, it is important to note that the washing water in the end cooler will flow out through the distillate collection tube after turning the tap back on. The tap should remain in a vertical position at the end, as this ensures that the distillate will flow through the end cooler into the distillate collection tube. Once the water has drained, place the distillate collection tube back into the parrot's collection position. Before starting the emptying process, after the distillation is complete, the machine is still hot. We can see that the mash temperature is above 90 degrees Celsius, so we should gradually pay attention to occupational safety in order to prevent scalding accidents. Before draining the waste mash, it is a good idea to remove the door and cool the mash down slightly to reduce its temperature. The mixing motor operates during the process. The least preferred technique is emptying into a bucket. In this case, after each opening and filling of the bucket, the tap must be closed, as this can easily lead to blockage. If you are emptying into a bucket, We recommend waiting for the mash temperature to drop to around 50 degrees Celsius. A much safer method than emptying with a bucket is to connect the spout directly to a drain, so that the mash can drain by gravity after opening the tap. During emptying the mash, the cooling and dilution of the mash is assisted by a drain rinse tap concentrically welded into the outlet bend. Before starting emptying the mash, place the alcohol meter in a safe place and empty the distilling parrot. To illustrate the emptying, the column is now removed, which is not necessary under normal circumstances. After emptying, you can turn off the mixing motor, and the electrical main switch can be set to the default position. Then we can start cleaning the kettle.